Hello, I'm Arifuzaman. I'm going to talk about Weyl Fermion. And there is a subtitle you can see, Weyl electronics. Well, there are 1,000 type particles. Probably there is a million. We don't know yet. So why Weyl Fermion? To understand this, we just simply go through this lecture. Well, to understand what is Weyl Fermion, first, for example, what is Weyl? Weyl, named after German scientist Hermann Weyl. And fermion, you all know that fermion is a kind of particle, a class of particle. Well, to understand Weyl fermion properly, we go through the standard model. Okay, come to the standard model. Well, standard model mainly consists of two types of particle. One is boson and the second is fermion. Well, the example of boson is photon and the example of fermion is electron. You all can see, you all know probably. Well, so let's talk about fermion. What is fermion? According to its definition, fermion has fractional spin. You all have to remember that because that's so important. And another properties of fermion is it follows Pauli's exclusion principle, and another important properties of it is an elementary particle. Okay, go to the next section. What is Weyl fermion then? You all have known from the previous section that a fermion is a kind of elementary particle. So you all can assume that it should have a mass. Now come to the point. This is a massless fermion. Isn't that amazing? It's a fermion and it has no mass. After all, and again we have said that it's an elementary particle. We can see that Weyl fermion is also a particle, but it has no mass at all. But according to definition, it must have some charges. That's why it is fermion, isn't that? Well, another amazing properties of it is it can act as a matter and antimatter. We didn't go detail about that because it's so difficult to understand in this level. So we'll simply see that how Weyl fermion is so amazing and exclusive than another kind of fermion. Okay, two things you have to remember. As we have said, it has no mass. Weyl fermion has no mass and it is an elementary particle. And it has also charge. Okay, come to the next section. You can see there, let's assume this is an electron. Well, we all know electron carries charge in the electronics gadget, and that's how we get electronics. We call it electronics. Electron has mass and it carries charge. Okay, now let's assume it's kind of sad. Isn't that? You can see the sad face of the electron because it has some mass, so it had to do a lot of work. It becomes so exhausted carrying the charges with a mass. So electron is kind of slow mover. Well, another problem of electronics is when an electron is scattered around the electronic path, that must have destroyed when it collided with something. Now come to Weyl fermion. Now Weyl fermion has a charge, but it has no mass. Then when you don't have mass, you can run more fast than your friend who has mass. Isn't that? So it is so happy. You can see, let's assume that Weyl fermion, and it is so happy, is smiling because it has no mass. Thus it can also carry the charge. So when it has no mass, it must be carrying the charges 1,000 times faster, 1,000 times faster, 1,000 times faster. Well, isn't that amazing? Well, 1,000 times faster. Again, I am saying that. Actually, the measurement is not scientifically proven, but it is gonna be more than 1,000 times faster, of course. Well, so what we're gonna get is electronics. Amazingly, we can replace the electron with Weyl Fermion. Isn't that very interesting? Because you are replacing the electron which is mass, and the Weyl Fermion has no mass. So we can get a new type of electronics which we are calling electronics. Well, come to the next advantage of it. Okay, we see that quantum computing. Now come to the classical bit of a computing system. A classical bit consists of a 2-bit 0 1, and a qubit has also 0 1, but a Weyl Fermion, as it moves so fast and for its unique properties, so the quantum computing is not a dream at all. We're going to get it soon, because we can see that in the quantum computing system, I mean qubit system, the electronics going to help a lot more. Now drop every possibility of using it as XY. Well, let us assume that XY is any kind of amazing thing, like I'm saying quantum computer and XYZ. So just think how amazing is this to discover something that had predicted theoretically 83 years ago. 83 years ago by Hermann Weyl. Just like Einstein quote, it seems the nature must have a scientific formula to explain itself. Oh, how amazing is this? This has been predicted 83 years ago, and it has been proven now, some months ago, by Dr.Jahid Hasan in the laboratory of Princton University. So after 83 years, we got it. Isn't it so amazing? So welcome everyone to the interesting world of particle physics. Hope you all enjoyed the video, and apology for my mistake if I have showed you any wrong kind of information. Okay, thank you everyone.
Austin.